Okay, we will continue. The issue is that my Las Vegas map, is a, very odd, um, because because here it shouldn't be developed area, so that's the downtown area, which shows barium. I think the classification has something wrong, and I don't. Um, I I think I'll have to redo it. It's okay. Um, and there are some other issue as well, so I just have to come back to redo the session. But now I'm going to move to supervised classification. So for supervised classification, again, we will use the Landsat satellite imagery, but this time, um, but this time we will use supervised classification. And supervised classification begins with users collecting examples of the classes they would like to have appear in the final classified map. And these examples are known as training samples and are used to classify the spectral properties of the different features are used to classify the spectral properties of the different features in the scene. So to perform this classification, we will use the maximum likelihood classification tool, and this tool requires input from multiband rasters and a corresponding signature file. Okay. Okay. So now we have to calculating supervised classification of Chesapeake Bay. So build skills in the areas. So now we're going to perform a supervised maximum likelihood classification, calculate percentages of land cover of different watersheds, and compare the percentages of land from maximum likelihood classification with the unsupervised classification derived in Module 5. And we need is looking at the scenario, so I'm going to save everything and close it out, and I will restart once I have it. So after examining these let me show my map real quick right here. So I laid it here. So this is the unsupervised. I will make a supervised to create. I remember I added here, so I think I might forgot to export it. So I'm gonna update it. So I remember I add a title here. Um, after examining the unsupervised classification, which is right here, of the three Checopay watersheds analyzed here, so the Checopay Foundation has asked for a supervised classification of those watersheds, and I'm going to export it again. Click export and replace it. So now it should update it. There. So, um, So the foundation wants to analyze the watersheds based on the same classes: water, developed land, forest, and crop pasture. And the foundation would like a maximum likelihood classification using spectral signatures along with the percentages of these land types to analyze the type of protection and restoration needed for each watershed. And the foundation would also like a comparison with the unsupervised classification from module file. So, um, Okay, so deliverables. So the following deliverables are recommended for here. So we have to do a maximum likelihood supervised classification using spectral signatures with 4 classes of land cover, water, developed land, forest, and crop pasture. It's the same. So that's here. And then comparison of percentages of land cover of maximum likelihood supervised classification and the unsupervised classification from module file. 5. And a written analysis using maps in PDF format. So I exported as a just map format. So I could change this into transparent so it'll look a lot nice. But I think I like it this way. So North Arrows is too big. So I can just put it a little smaller. Yeah, and to the right. So there are some work could be done to make it a lot nicer. So the questions in this module are both quantitative and qualitative, and they identify key points that should be addressed in the analysis and a presentation. So, and the data, I already have it. I do not have to do anything. So now I'm just have to start a new one. So the new one I will call it gonna exit out. So ArcGIS Pro. For ArcGIS Pro, that I'm gonna do is that on the right hand side corner, that blank, so that I'm going to save it in my folder. So go to desktop and right here, in here, and then book data, right here, and making spatial decisions. Oh, no, 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 no. Okay, so my folder, click OK, and here I'm gonna rename it to Soup Chesapeake. Okay, and results. Okay, and that's the document name. And once it's started, I just insert new map and go to analysis tools. So, and bring my data. So folder, right click on it and add the data. So, okay. Alright, connect to my folder. Okay, superb. Yeah, so Chesapeake Bay, geodatabase. I don't think it's in here, so excuse me. Chesapeake Bay results. Okay, so oh no, Chesapeake Bay results. Where did it go? Not in Las Vegas, so So the data, let's see. Oh, New Bay geodatabase. Okay, it's in New Bay geodatabase layers. Right click on it and then add to current map. And for the mosaic, I just right click on it and add to current map. So I add everything now. I have to kind of, how come the state, oh, just a weird color. Okay, that's fine. So then I'm gonna do is rename everything. The first one is highways and the second one is area of interest. Area of interest. And then selected shed rivers, selected shed rivers, selected shed rivers. Okay, selected shed rivers, selected shed rivers. Okay, and then shed rivers, and we have a rivers, and then we have the multispectral after rivers, and then study area. Okay, study area, study area, and then we have Study area, we have Bay watershed. Okay, Bay watershed. Okay. Bay watershed, and then states. And I have one more. Selected sheds. Okay, selected sheds. Selected sheds. Okay, right here. Selected sheds. Okay. Selected sheds. Okay. Alright, perfect. Everything is here. So now a good time to familiarize with the data. I'm not gonna go over, so I will save everything. So let's look at the projection again. So property. Go to source and scroll down. So it will be an ID UTN. So I think I'm gonna just change it. UTN NID 1984 UTN 18. Okay. Oh, weird. Okay, let me look it again. Source NID 1983. Okay, 1983. 1983. 1983, not this one. Okay, it should be this one. Click OK. There. So, and we will set the environment. So, analysis, environments should be all set except for the coordinates. So, coordinates it will be, okay, NID 1983, UTM zone 18th. Perfect. Everything is set, and we will talk about the create a process summary. So to create a process summary, that is simply a list of the steps we used to do with the analysis, and the summary allows us to or others to reproduce the work. And we can use a simple text document for the process summary and keep adding it to it as we do the work to avoid forgetting any steps. And this shows the first few possible entire in a process summary. So the first one, we download the data, we extract the map package a while ago, and watersheds with streams, places, and highways. And then number 3 is perform a supervised classification. Number 4, produce training samples from known locations of desired classes, and develop a signature file and run classification. So the analysis, once we have examined the data and set the environments, we are ready to begin the analysis. And to complete the deliverables, we must address the problem. So here in this module, we must perform supervised classification. So the step 1 is deliverable, a maximum likelihood of supervised classification using spectral signatures with 4 classes of land cover, water, developed land, forest, and crop pasture. So now I will identify and map designated watersheds. So we will turn on and rename the selected watersheds. So I think I have a watersheds already. No, selected sheds, and this is just watersheds. And we will zoom to watersheds, zoom to layer. So right click on the watersheds, and I'm gonna label it. So the 3 label that we already did, and I'm going to turn this on. And Sheds River, rivers, and I'm gonna rename it Sheds River. And I do not need the area of interest, so I'm going to change it here to Sheds River. Okay, so I have a Sheds River, and then I want we will analysis toolbar, click clip. So for clip data, so input, it will be highway. So geoprocessing clip, that is weird. So why I can, oh, highways, go to tools, clip, data management. Oh, so there are 2. So I have to do a spatial analysis. So clip tool, So I need highway and then watersheds and output feature. So I'll just say highway clip, that's fine. Or I can just say roads. Click run. Once we click run that, alright, then I'm gonna close it out. So then I remove highway so that the roads is just inside our features. So now I'm going to right click on roads and go to symbology. Let's put unique. So then I will add highway type and go to more and do not show this. So for highway type, we should be good for now. And then I'm just color coded. This is highway. Go back. Interstate highway. So I'm gonna just label it interstate highway, interstate, and then state highway. Okay. State highway. Okay. US highway. Okay. Just say US highway. Okay. Alright, so the roads are all added. So I'm gonna right click on it and go to symbology again. So double check everything. So property, that's too big. Just do 1.5. Okay, 1.5. It doesn't like it. 1.5. 1.5. Click apply. Go back. Okay. 1.5. 1.5. Okay, 1.5. There. Click apply. Go back. And then here. 1.5. 1.5. Okay. Click apply. There, look a lot nicer. So, then I'm gonna do is clip multispectral Landsat scene to select to the selected watershed boundaries. So in this contents pane, we will click raster functions analysis group, raster analysis. Oh no, raster functions. So I'm not gonna do this. So I have to select this. Click yes. Alright, so click this and then I'm gonna go to imagery, so then raster functions. So for the raster functions that I'm gonna go is find the clip. So it would be data management clip. There. So that we will do multispectral outside, and the clipping feature, it will be watersheds. Okay, and use this and create a new layer. And can turn this off. So the clip layer should be inside, and watersheds, and just make it no color. There, click apply, so that we can see our satellite images. So what is the square area? Okay. So we were collecting training samples. So to do that, it's kind of a little bit a lot of work, but we will deal with it now. So we will do is that collecting training sample. So in a supervised classification, we already know the classes for the study site, and we have a sample locations in the study site that represent each class. So here we will create a land use map from a satellite image, and the classes are water, developed forest, crop, pasture, and wetlands. So we must assign each location in the study area to a known class. The more sample locations we identify as belongings to a class, and the more homogeneous the cell values are within a class. So the better the resulting classification we could get. So the location identifying the known class location are called training samples. So that's a key concept. So training samples, so that location identify the known classes. Training samples. So here we will I restate again. So in a supervised classification, we already know the classes for the study site, and we have a sample locations in the study site and the represent each class. So we create land use map for satellite image, and the classes are water, developed forest, and crop pasture, and then wetlands. We must assign each location in the study area to a known class. So the more sample location we identify belong to the class, the more homogeneous the cell values are within a class. So the better resulting the classification. So this is training samples. And we can identify training samples with a polygon superimposed on a raster. So in here, so the multispectral 2006 is the reference raster. And this raster is displayed as a background and used as a reference to identify areas to encircle when we produce training samples. So wetlands are usually found near bodies of water, and forests are large green areas and are not necessarily adjacent to water. Crop and pasture lands are usually green-brown in color and can be identified by their near rectangular shapes. So now I'm going to select 2016 Landsat 2016, so I'm going to rename it. So this is called Landsat 2006, and we select this image, and we will go to select classification wizards. So the same way, in the configuration pane, we will use the following. So this time we will do, supervised pixel based and class schema, and use the default, which is the NLCD, National Land Cover Dataset. And output location, it will be my data folder, so that's fine. And training samples, didn't mention, and we will do next. So open the training. This is the training sample manager. So the training sample manager is divided into two sections. So that we will do something here. So now, the training sample manager divided into two sections. When the first opens, we will see the schema management section at the top right here. So this section will automatically load based on the selection from the configure pane. So in a NLCD 2011, we can create new classes here for remove existing classes to customize the schema. So we will need the following divisions: water, developed, and forest, crop, pasture, same as planted, cultivated. First, we will remove several existing class. We will right click on barren, so right click on it and remove class. Click yes. And then repeat this, and we will delete the shrub land. Right click on delete, click yes. And herbal bakers, right click on remove, click yes. And wetlands, right click on it and click remove, click yes. Very good. And then the four classes we're going to use. Okay, so now we're going to create the training samples. So from the training sample manager, we're going to select the class which we want to add samples. So now we're going to select the polygon sketch tool to begin collecting the training samples and digitize polygons on the image to match the training sample. So which I have to do. So water is right here, so I'm gonna collect more samples. So that water, add water, so water, I don't need to add more. So this is water, so this is supervised water, and this is water. Okay, and this is water. You can see the water meanders. So I'm gonna zoom out a little bit. So and then hit Control C. I'm going to pan a little bit. So and zoom in. So these are water as well. Just let it render a little bit more. Okay, I'm zoom out a little bit. Oh, no, no, no. So if I did something wrong, then I would just click exit. So, and I'm zooming a little bit, and then, oh, click water again. Alright, so water and choose a polygon. Alright. This is selected, okay. I think I have everything already. Water. Okay, so I have a water here, and I don't need to show these. That's crazy. I just want my area imagery. I don't even need the states. So, it's not huge good quality. So, and I have a water, develop. So now I'm gonna do develop. Let me, next, previous. And I need to collect samples a little bit more. Okay, water. And right here is water as well. Okay. Zoom in. Oh no. Click. I don't want to be selected. There. I should have enough water. Okay, then I'm going to do develop. So develop 1 and move around. Okay. 2, 3, 4, 5, 6, 7, 8, 9, exit out. Okay. And a little bit more. Okay. So now I'm going to move to forest. So 1, 2, 3, 4. Those are pasture. Okay. 5, 6. I think I have enough, and then I will do planted, cultivated. So now 1. Okay, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 10. So next. So once I collect those samples and polygon sketch, and I'm zooming and get the water. So I have the polygon, and I and I always did that in training sample manager. So now I'm going to follow the parameter classify. It will be support vector machine, and then maximum number of sample per class, it will be 500. So once I have the 500, I will click run. Okay, run. So once I run, click run, and here it says clicking run to create a temporarily preview classified file and appear here. So and next we will open the classified pane and use the following parameter. So just wait a little bit, okay? So this is supervised. And unsupervised we already did, and there was a skimmer, and I used to do that in Erdos. So but now ArcGIS Pro can do it a lot more. Okay, and then once we have the preview thing, and click next. So to open the classification pane, so next. All right. So this is the classification pane. So now classified and classify form do not save anything. So we will put next to open the classify pane. So output classified data set, I will say supervised. And supervised, I will say supervised, and save. Okay, and then do not save classifier form, and go to run. So this pane allows us to save the result if we do not want to use the save output class definition. So the file ECD right here. So the segment image, we would just leave this blank. So go to run again. And then once we're done, we just click finish. So, and because what we choose and it just classify for us, it's really nice. And it's not rendering the whole thing. That's weird. Oh, it is. It just slow. And then we will have to do is perform post-processing. That's really nice. Developed a land. I just need to make it more pink. It's just really dark. I need to make it more pink. I like it more pink. There. No. Can I change more pink? There. So it pop up nicely. That I can see this area as more developed, so that okay, to succeed and next, and everything is here. Next, can I change the color here? That's a good question. All right, just wait a little bit. I don't want to crush everything. Classifier. So classifier, go to previous real quick. I don't think I can change it. Just no. All right. So next, okay. So now I think maybe I can do it here. No. So click run and then click finish. Finish. There. So and now we can move to perform post-processing. In the classify output, some isolated pixel or small regions may be misclassified, and this output gives a salt and pepper or speckled appearance. So the post-classification processing removes noise generated by these errors and improves the quality of the classified output. And the generalization analysis tools are used to clean up enormous erroneous data in a raster or generalize the data to remove unnecessary detail for a more general analysis. So the erroneous data can result from several common resources. So the first one is classified satellite imagery may contain small areas of misclassified cells, and conversion issues can arise from rasters having different formats, resolutions, and projections. So the generalization tools help identify these small areas and automate the assignment of more reliable values to the cells that comprise the area. So the majority filter and the boundary clean tools that we used before, which we also use in the unsupervised classification, can smooth the the zone edge. So we will use these two tools to post process the supervised classification. So now we can zoom in and look. It is a little the classified image looks, is it packled? Does it have a random pixel not assigned? It could have, so it's just very coarse. But once we zoom out, it kind of makes sense, and we have the water, and some parts of the water kind of like got break up, so might be misinterpreted, or some trees cover it, so you can see our waterways got messed up, and maybe we should collect more data somewhere there. Okay, so let me put this up, so I'm kind of just turn it on and off so I can compare better. And then we will run the majority filter tool. Let's just wait until it render a little bit, so then I will turn it on and off, on and off. There. So we do see this is very tiny roads, so it didn't get interpreted, but once we zoom in, we see the waterways there. So since it's area imagery, it just takes so long to render a little bit. So now it's okay. Let's just wait a little bit. It is still rendering, and I'm gonna save it. If not, I'm gonna lose my data. Even all those layers are not showing up. Okay, so let's just give a little time, and then at the same time we could talk about the majority filter tool. So we used it before, and the majority filter tool will remove misclassified isolated pixel from the classified image. So now I can see the waterways a little bit, which is kind of a good job. Think about this. So yeah, I think they interpret a good job. So pasture land, that's a lot of pasture land. So yeah, instead of more of the green, so we can see the accuracy. So yep, all right. So now we can do turn this off. So I'm gonna do is go to the majority filter tool. So majority filter tool. So that in the analysis tab, go to tools, majority filter. Type in, and it will be spatial analysis. So for the majority input raster, it will be our supervised. Okay, supervised, save. Okay, so output raster, it will be I'm gonna rename it. So SUPMF, and the number of neighbor to use, it will be 8, and threshold will be majority, and everything is all set. I'm gonna run. So in the majority filter again, so we're going to change use this again, but I will do input raster, go to MF, and then superb, I will do 2. And the same parameter, 8, okay. Output raster, 3. Or 2. Click run again. Okay, once I'm done, next we will use the boundary clean tool, which will smooth the rect class boundaries and clumps the classes. So now close it out and go to tools and then type in boundary clean tool. So double click input raster. So it will be majority filter, and this one I'm gonna change it into bound superb SUP MF2 BC, and I will use ascending, and then I'm gonna clear this run expansion and shrink twice. Click run. So once it's done running, then I will have to do something. Okay, it's done. Then I'm gonna so remove supervised. That's too many, so I'm gonna remove everything here. Okay, and then superb MF2, superb MF2. I just leave the BC. Okay. Remove. 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 So now next we're going to do symbology. The first one water, the second one developed, and the third one will be forest. This one want to go. So go to symbology. Okay, first one is water. And number 1, it will be develop. And forest. And crop. And pasture. Okay, use the color code that I used before. So this is water. This is water. And if I don't remember, I have to compare again. So water. Nope. I used the blue one. A little more blue. I guess. Is this one or... Nope. There. That's the water I used. Developed. I remember it's this pink. And forest, I use this green. And then the last one is crop is yellow for sure. So it's a little different. Oh yeah, it's the same. I'm gonna change the green water. It's the same forest. Forest. Not this one. Let's compare again. So I don't think it's this color. Could be a little troublesome. Which color did I use? A little. This one. There, it's the same now. Water, developed, and crop, okay? Alright, so now ensure that each square is appropriate color and close the symbology. Of course, I'm gonna save this into sharing, save as a layer file, land cover. So I'm gonna just say land cover. Now we're going to do is deliverable 2 and comparison of percentages of land cover from maximum likelihood supervised classification with the unsupervised classification from module 5. And next, we will qualitatively compare the three watersheds using the maximum likelihood supervised classification. And on the selected shed and on the map tab, so in the layer group, we're gonna select rectangle, and I will do highlighted. And the first one, extract by masks, and I will have to extract it. And the first one, it will be Pontomac. Okay. So go to watershed again. So go to map and go to select. There. So that's the one I have it, and then I'm gonna go to click this in imagery and go to clip. So for the extract by masks, oh, this time I have to use extract by masks. Okay. Extract by mask. Extract by masks. Extract by mask. Okay, input it will be this, and then mask it will be our watersheds, and then output feature Potomac, and we're gonna run. And once I have Potomac, I right click on it and use landscape. Go to symbology and import symbology folders, this, and land cover. Alright, then I have it, and I will do is do the second layer. Okay, so go back to my map and select watersheds, and go back to map and select again. I'm gonna do is the second one is Pontozax. Okay, so the same procedure, and this time, okay, is Pontozac. Run. Symbology. Gonna import it. There. So once we import it, yeah, we make sure we just have one this county, and then I'm gonna do one more. So then go to select. I'm going to open this up and do the last one. This is the last one, and then I'm gonna rename it. It will be Servant. Like 7, Servant. Okay, click run, so then I will have it. Okay, I'm gonna uncheck. And I have a servant, right click on it. Import, land cover. Click OK. Okay, close it out. So uncheck this. So, yep, I have everything clear. Selection. Close everything out. So, okay. There. So the three parts, everything is here. So we look at each of the three watersheds to write a comprehensive analysis and address the following question. So what is the dominant land cover of each watershed, and which watershed has the greatest imperviousness? And which watershed will have the greatest runoff from agriculture? And from the land cover classification, we have to identify areas that would be the most vulnerable and areas that would benefit from restoration, and include images of the watersheds in the report. So that we can see the cropland, and this part could be a lot, and then the same here too. The one has more forest, that will be a lot better. Okay, so now we have to do calculating land cover in each watershed. So in the previous section, we qualitatively compare the watersheds based on observation. Now, we have to tell a good deal about watershed land cover by examining the images. We can provide more detail with quantitative measurements. So in this section, we can do is calculate the percentages of the different types of land cover in each watershed, and we can do this calculation because we know both the total number of pixels in the watershed and the number of pixels of each land cover type. So now we open the attribute of table of the Potomac. Open attribute table. So I'm gonna do is for the summary statistics, right click on it and do statistics. So for statistics, oh no. Okay, so right click on it, go to summarize, and for sum, I'm gonna do is Potomac and Potomac statistics, and we will do the count and sum, and I have to cross this out, and okay, click run. And then I'm gonna open it up and we will have to calculate everything. So the first one, I have it. Let's scroll down. Open attribute table. So the first one is 37390131. There. So 3739031. Okay. Once I make sure that I have this, and then I'm gonna do is I will put things together, and then later we can compare. Alright, so now I have this, and I have to do the second one. So pawn text, an attribute table, right click on it, summarize, and then summarize statistics, count and sum, close this out, run, and I will do the other one for the 7. Okay, now go to 7. Alright, 7. I like count, close it out. Okay, run. So let's look at the second one. Open. Those two runs very fast. So the second one is this is Potomac, and this will be Potozaxt, which is 2651922. Okay, and then the last one. Oh, scroll down. Alright, open. So 7, it will be A74016. A74106. Okay, then I have it. Once I have it, I'm going to calculate everything here. Okay, so now I'm gonna add a field. So add a field, we will call it percent. Type will be float. There, and percent. 1. Click OK. Click save. Alright, the same here. Add a field. Okay, percent. Float. Percent. 1. Click OK. Click save. Okay, and then 7, it will be add a field. Okay, percent. Okay, float. And percent. 1. Click OK. Click save. Alright, so now I have everything, and I'm just calculate the fields. First one, right click on it and calculate fields. Potomac. Okay, it will be count divided by 3739031. Oh, 3739031 and times 100. Click run. 3.7, 30. Oh, it's close. It's not perfect close, which is fine. Okay, because the way you cannot just always get exact number, but you have to be close, okay? So, and we have count and divide, and we have 26515922, and you have to times 100. Click run. Alright, so that's fine. And this one, right click on it, calculate field. It will be count divided by A74106 and times 100. Click run. This field is a little bit more. Forest. This one I have a lot different. Okay, but I think they have some issue here. Okay. Just use the data I have. That's fine. Okay, then as long as here is developed area instead of let me look at again. Drag on top. Yeah, I don't see a lot of towns there. So I do see a lot of towns concentrated here, so I should be good. Okay. Alright. Now uncheck here, so it looked good to me, and except this area they didn't do a good job. It just depends how many tools you collected. Okay, so I have everything, and I got everything calculated, and I'm gonna export it as a map. So number 3, we are gonna finish it up. So number 3, we will finish up for making the map, and once we have the data, and this time we are a lot familiar with everything, so we can compare the supervised and unsupervised. And then for the Las Vegas, I could do it. It just hopefully we do not run into any issues, and maybe I have to redo parts of the Las Vegas part because they didn't interpret it correctly. It wasn't showing up a lot of features. So okay, now for the presentation of the analysis. So on the Insert tab. So go to Insert tab. I'm going to go to a new layout. For a new layout, the same way, portrait, a ladder, 8.5 inches to 11 inches. So that I'm gonna do is there. Going to close all these out. No need to zoom to page. Okay. And then I'm gonna to add my map frame. So my map frame added. Okay, I'm gonna zoom to layer. There. So once I'm zoomed to layer, everything should be all set. And then I'm gonna click this frame, double click on it, go to format. Once I'm in format, and I will reassign here. So here to the left will be 0.044, and the height will be 3.4, and the width it will be 7.5, and this it will be 6.5. It is still a little weird. I'm gonna drag it a little bit. So now it look a lot nicer. Go back to map and oopsies. Map. Zoom to layer. There. So I need to activate. No, I don't because there is something down here. Okay. I think it's perfect now. And now I'm gonna to insert scale bar and north arrow and a lot of things that I will make a map similar to the one we have it here. Let's see, where did it go? There. So I'm gonna make exactly like this one, but this time a little different. So I'm not gonna use error imagery. I will just use the same way, but one is supervised and the other is unsupervised. So watershed developed land. It's just a huge difference. It's interesting. Look at the color and everything. So so for scale bar, scale bars provides a visual indication of the feature size. So I'm gonna add exactly the same. So I forgot the let me change it into 100. Okay. I think it's the same now. Nope. How come here is California? Oh, maybe the city or that's fine. It look a lot different. This is really blurry for the let's see, topographic. Okay, so gonna make a similar one. Baltimore. Move my north arrow. So let me change watersheds. Go to properties. No, go to symbology. I haven't added my north arrow yet, but it's okay. Change the color. Outline color, it will be this one. Okay. That is too much. Okay, I'm gonna use this as a reference map. So the two maps could look a lot different and I don't need the highways. There. I don't need the highways, it's not important. Alright, back to our layout. So layout and insert scale bar for the miles. There. Okay. Okay, so then on the insert, I resize the scale bar to 20 miles and insert the scale bar in the lower left corner of the watershed comparison map. So I did. So and insert a north arrow. So north arrow will be the same. So we'll put it right here. Oh my god. What happened to this north arrow? Oh, there. Delete. Okay, I have a north arrow. Then I'm gonna do is insert the legend. It's just slow. Okay, back in here. Back my layout. Layout. Okay, go to insert. I need to be back in my layout. Okay. It's too big, so I need to move this a little down below here. Yeah. And I need to label them. I do have a neat line, which is fine. I need to. How do I go back? I'm gonna insert the chart first. So I need to open ArcGIS Pro. I think I just copy everything from the other one. Unsupervised. Let's do it side by side. That we can be consistent. And I think everything should be the same. I think I just copy this, copy, and move this out. Go to layout, insert, format. Have to be back in my layout. The title. Copy. Paste. I need to make this a lot bigger. There. And then this down a little bit smaller. There. Okay. Let's see. This is a lot smaller. The table should be fine. And I just have to put new data. Could be an issue. I need to bold this. And I need to label this. The issue was, isn't it the paper is a lot different? Why I have so many spaces here? Okay, so I'm gonna format this there. So format there. So I'm gonna do it the same here. Go to format. So here I'm gonna put is 0.3. And let me do this is 8. There will be 8. And then 1.7. 1.72. There. It's the same paper. Yeah. And it just, the spatial reference is different. Can I do 700 here? I definitely could. There. So this is supervised, the other is unsupervised. So I'm gonna say okay, everything is the same. Now I just have to change the data. Perfect. So my data, I'm going to open the attribute table. Yep, save it. Oh, I need to export it again because I changed that. Alright. I will export later. So, let's see. I need to change this to 20. The source should be good. Oh, I don't think this can be edited. Let me see. World document. Could be an issue. Paste. Well, then I'm gonna do is last time I did making the table again. So since it's not, we could put the two table together and compare it. So but I don't think I will put it together. I just produce this two map together. How come the words just look so different? There. I just have to make a table. I will do it, but for now, I'm going to do the watershed label. Okay. So the labeling. Where is the labeling? Okay, right here. Watershed labeling. Click right here. So symbol. It will be halo. Halo. Go to white and click apply and symbol appearance. So I don't have to bold, I just have to make it bigger, 18. Click apply. It's too big. I think I did bold it. Bold. Click apply. Let me compare the one I have. Oh, I need to change them first. Okay, I don't have to bold it. It's 18, it's fine. Regular, click apply. Right click on it and go to attribute table, and I'm gonna so calculate field equals to field name. So, and then dot upper, click run. That should do it. Yay, it worked. So, and then, this thing just move up. And I could convert it to graphics, so I move it down. Label property, so I'm gonna do formatting, position, placement. Lamp puzzle. There. So lamp puzzle, that will fix it. There. So, okay. And make it a little bigger. And I do need a rectangle. Insert. Bring the unsupervised back and copy the rectangle. Okay, unsupervised. And I still need to change the data. I wouldn't worry about it right now, but the data is very important. Okay, group. Rectangle. Copy. Where is the... Oopsies. Click Z. Control Z. This is not this one. Group element. Where's my rectangle? Oh, this one. I guess. There. copy, and rectangle before the map frame. Paste. Okay, rectangle, drag it down. There. Make it bigger. There. Okay. Land cover. I do need to ungroup them. Land cover. Added text. Format. Bold. Can you bold it for me? Bold. Bold. Didn't need bold. What is the text? Ungroup. Format. 15.5. 15.5. I don't need a bold. It just look different. Okay, so we have two maps. I'm going to change the down here the data, so we are down. Okay, and then we will do the Las Vegas. Hopefully, I will be able to do the unsupervised. If not, and I have to redo it. I think it's just the reclassification. It really messed it up there. Because my area just have some area that is not developed area, so I don't really like it. Okay, see you next time.